Hello and welcome back. This is Barrett from Cypress College, and in this lab today we're going to cover the AWS Academy working with EBS, or Elastic Block Store. So this is a pretty straightforward lab. We're just going to look at creating volumes. We're going to then look at attaching and mounting those volumes to an EC2 instance, and we'll also see how we can create snapshots through those very simple point-in-time backups of our volumes, and then how to essentially restore a snapshot volume back to an EC2 instance. So in the case of this lab, let's say we accidentally delete something and then we need to restore from a previous snapshot. So that's this lab in a nutshell. And really, EBS, the easiest way to think of it is just a hard drive or storage for your EC2 instances. And the cool thing about these is they can be mounted to across different EC2 instances, not necessarily at the same time, mind you. That's something we'll look at more when we look at EFS, or Elastic File System. But with EBS, you could have a storage volume, and then if in the future you need to attach that to other EC2 instances, it makes it very easy to do that. And also, looking at snapshots, you could easily create a snapshot of a current volume and then attach that snapshot to a second EC2 instance for whatever your requirements might be. So let's just go ahead and hop right into the lab. I already have it started up here, so you can see I have my management console. If you're following along, you will likely have the very detailed walkthrough as usual. So I'm going to move this over to my left side here, so I don't have to be switching back and forth. And something I wanted to mention too, the really cool thing about this lab, it kind of has a little bit of Linux system administration built into it, because you get to kind of mess around with mounting these drives, mounting these volumes, I should say, to the EC2 instance. And we're also going to look at using PuTTY, since I'm currently running on a Windows machine. If you're on a Mac or Linux machine while working on this, the lab documentation also details how to SSH into the EC2 instance through your terminal. But in this lab video, we're going to use PuTTY from a Windows machine, which I think a large majority of people may also be using. So let's go ahead and get started by creating our first EBS volume. So to do that, we want to actually move into the EC2 service. So I'm just going to go search for EC2. And you can see we have a lab instance here, which is what we're going to be working with and attaching volumes to. Now, on the left-hand side here, under Elastic Block Store, you see we have volumes. And one thing I do want to mention, just make sure that throughout this lab, it will default to US East-1, North Virginia. Just make sure that you do remain in this region for the lab, so that everything is, created in the same region. Okay, so you see we currently have two different volumes. They don't have a name, which isn't necessarily best practice. I would definitely give them more descriptive names. But if you scroll over here and see attachment information, we can see which one is attached to that lab instance. So it's this one up at the top here. And you could see when you select it, you get information about the volume down below here. But we're going to go ahead and create a new volume. So we'll just click the Create Volume button up here. Let's just keep it simple. We'll do a 1 GB volume. Very important, make sure that you keep within the US East-1A availability zone, but do note that you'd have 6 different options if you wanted to, have an EBS volume in multiple availability zones for potential high availability. Now, I will say that security best practice, we should encrypt this volume. EBS should always be encrypted. But we will leave this unencrypted for this lab just to keep it simple, and make sure we don't run into any dependencies that maybe this free lab does not provide. But equally important is tagging. So this one here, we'll just say the name of this is my volume. It's always best practice to tag your resources accordingly so that not only you, but other people who you may be working with understand very quickly what this volume is potentially used for. Okay, so we'll go ahead and create that volume. And you could see it was pretty much as simple as that and pretty straightforward. We now have this volume available. So now we want to go ahead and attach this to that lab instance, that EC2 instance that we saw. So here you see we've named it my volume. I'm going to select it and just go to Actions, Attach Volume. And here we will select the lab instance. Very important you select the right one here. And you notice that it automatically gives it a device name. So this is kind of where we kind of touch on Linux system administration, and you don't need to know full in-depth how to use Linux to get through this lab. Just know that Linux essentially treats everything as a file. So even a mounted drive gets placed in the /dev, which is short for devices. It gets placed in the /dev folder, and then this will be the drive folder, SDF. So we'll just go ahead and click attach. And you notice the change happen over here. It's currently in a attaching phase, which generally this stuff, yeah, there you go. It's already attached. So it happens pretty quickly. You can get to see other things like volume status, make sure it's healthy. And if we were to have encrypted it, it would give the encryption information over here. All right, so now the next step is to connect to our EC2 instance. So for some of you, this may be the first time that you're actually remotely connecting to an EC2 instance through SSH, or remotely connecting to anything in general. So for that, the lab does have a download link, and let me grab it here. So this link right here that's from the lab, it is safe to download. So this putty.exe, I know normally sometimes you might think like, I shouldn't download an executable like this, but just make sure that it comes directly from the AWS Academy lab. You'll be fine. You could also Google search for Putty. It's a very widely used remote terminal application for Windows specifically. And you could even go to putty.org and you could download it right here. And I would say, yeah, if you're on 64-bit Windows, it would be this one right here up at the top. So a couple of different ways that you can get this. It's a very lightweight application, not very large at all. And I'll go ahead and start it up so you can see what it looks like. And this is Putty. Okay, so let me close out of here. So essentially what we want to do here, and one thing that the lab does recommend once you launch Putty, to come to connection and change this seconds between keep alives to 30. This will just help keep the session open longer than normal in case you're like kind of going back and forth between the lab. And then if we come back to session here, this is where we need to enter in the public IP address of our EC2 or our lab EC2 instance. So how do we get that? So we have to come back to our management console. We'll search for EC2. And so this is the instance right here. So a couple different ways. You can get it straight away from right here or down below. As long as you've selected it here, you have a icon here that you can actually click and you can see that it actually copies it to your clipboard for you. So that way I can come back to Putty, copy and paste that in. Now we're almost there, but the next thing we need is a private key. So currently, when you do this remote SSH connection, it takes place through asymmetric encryption, meaning there is a public key and a private key. So the public key sits on the EC2 instance, and then we, as the administrator, must also have a private key that corresponds with that public key. So I'm actually going to drag over the lab documentation, and this is essentially where this is the console for your running lab, right? So you can download the private key specifically for this lab only. If you click on details, go to show, and it's going to pop up a window here. So there's a lot of information here, but honestly, the only thing we need is the SSH key. And if you're running on Windows and using Putty, all you have to download is the PPK. Now, if you're on Linux or Mac, you would download the PEM. So I'm running on Windows. I'm going to download the PPK for my Putty instance. I'm going to go ahead and save that. All right, let me go ahead and load in. You basically just have to browse, or actually, I'm sorry, let me show you here first. You will go down to SSH, go ahead and click that plus sign, and then you'll see this auth section. So short for authorize, right? And now here you can see private key for authentication. Or I'm sorry, I said authorize, I meant authentication. So now let me go ahead and find where I save that to. Okay, there we go. So it looks like I had a couple other different labsuser.ppk in my folder. So to fix that number 3, but you likely will just say labsuser.ppk. So don't worry that it's slightly different. But as long as you loaded in that PPK file that you downloaded from the lab details, then you'll be good to go. So once again, just to review, Putty configuration is pretty straightforward once you get the hang of it. We are connecting to the lab instance that you see behind here at its public IP address, which is 44.195.128.240. We're connecting on port 22, which is SSH, secure shell. And then finally, we had to load under connection, SSH, authentication. We had to load that private key, that .ppk file that we downloaded. Now, when we press open, let me drag this over. You're going to get this warning. The server's host key is not cached in the registry. So you just want to say yes to this. And then you are greeted with a terminal screen, and it says login as. So on most of the AWS, Amazon to Linux AMIs, the default, I guess you can call it like the default root user is EC2-user. So that's what you're going to want to log in as. And now you can see that we have successfully logged in, and it is displaying our private IP address now, which actually you can confirm behind here is in fact the private IP address of that machine. All right, now this is the part of the lab where we're gonna kind of get into the Linux sysadmin kind of mode here. And there's a really handy website that I want to share with you. It's called explainshell.com. And hopefully we could use this, and you could also use this in the future if you're working on labs and they use Linux commands and you don't quite understand yet or don't understand the full context of what's going on with those commands. But I'll do my best to explain here as we move along. And recall that the AWS Academy lab walkthrough pretty much lays out which commands you need to run, but this video, it's all about adding context. So I want to make sure that you understand what these commands are actually doing. So first thing we could do is run a command called df-h. So df is short for disk free. And this is basically just showing us what available storage we have currently. So you could see there's some temp drives, but specifically here's that 8 gigabyte instance, or I'm sorry, not instance, volume that was originally attached to the instance. But we don't see that new 1 gigabyte volume that we created, and technically we attached it, right? But we haven't mounted it yet. So we don't see that displayed here yet. And just to give you an example, if we came to explainshell.com and typed in df-h, I know it's a fairly simple command, but you could see it'll tell you, okay, the command df, report file system disk space usage. And then -h, well, this gives it in human readable form, print sizes in human readable format. So that is largely related to, it gives you slightly better, more approximate sizes. So for example, if we just did df, you could see that it doesn't tell you if it's 404K or if it's 1.5 gig, and you kind of have to do a little bit more thinking on that. So human readable is often preferred for quicker analysis, right? Okay, so moving on. First thing we need to do is, and I'm going to go and clear the screen by typing clear. First thing we need to do is create an ext3 file system on the new volume. So we could do that by typing sudo mkfs. You can kind of think of that short for make file system. And then -t, we're telling it a type, and that's going to be ext3. And this is for, remember, when we created that volume in AWS, we were given the /dev/sdf for the volume. And essentially, sudo is, in fact, you know what? Let's use this as an example. Let's come to explain shell. So you can see how you could potentially use this. And in fact, I had searched for this earlier. You can see how you could use this in the future. So sudo is a very common command. Execute a command as another user. So this is usually used to elevate to root privileges, especially needed when you're doing like system administration type tasks like mounting new hard drives, changing configuration files, things like that. Because if I hadn't added sudo, it would have maybe given me a permission denied. And then this EC2 user is essentially in what's called a sudoers file, meaning that it is allowed to do to make sudo commands and run as administrator from time to time when needed. All right, so moving on. Now, like I was mentioning earlier, with Linux, everything is a file. Even hard drives that you're mounting, they are located on the file system. And so because of that, we need to first make a directory. So the command for that will be mkdir, short for make directory. And we want to make /mnt/data store. Okay, so that's going to be the location that we mount the drive to. And we'll go ahead and do that next with sudo mount. Which volume are we mounting? We're mounting /dev/sdf. And we're going to mount that to that newly created directory. Whoops. Okay, and now one final step. It's technically mounted now, but if we were to reboot this instance, it would not be mounted any longer. So we need to add something to a configuration file so that it will go ahead and mount this volume whenever the instance is restarted. So to do this, we're going to say echo. So we're basically echoing out this entire command, which is going to get placed into a configuration file. So I'll explain this a little bit more once I'm done typing it out. Okay, so, and this is another one where we can actually utilize explain shell. In fact, I have it in my previous searches here. So echo essentially is just saying, whatever I type next, just echo this out to the terminal. So this is essentially a line. It's considered a string, basically. It's actually not technically a command, even though it kind of looks like it. But what we're doing is we're sending this entire string. And when you see the pipe command here, actually, let me go ahead and search here. So a pipeline is a sequence of one or more commands separated by one of the control operators. Long story short, I don't want to go into the deep details. The pipe is saying whatever this string is, send it to what comes next. So it's sending it to this command, which is T. And T is a way to basically write to a file. So it's taking this string, it's going to write it to the fstab file that's in the etc folder. And this -a, if you look down here, that is telling it, I want to append this string. So I don't want to overwrite what's in there. I want to add to whatever is currently in that file. So this is a good example of a way of just adding something that you want to be a recurring thing, such as mounting this volume at startup into an existing configuration file. Okay, so that's essentially what we're doing here. So now we're almost there. And in fact, we can verify that that file was updated by running cat, which is short for concatenate. And this is basically just going to print the contents of this configuration file out onto the terminal. And you could see here that this was the previous line in that file. And then this is that string that we added into the file just now. And now if I'm going to go ahead and clear the screen. If we do df-h, we could see that that new volume has now been mounted right here. It's showing a little bit underneath the gigabytes. Yeah, that is our newly created volume right there. So we're on our way. And now one more thing that we're going to do that's going to become useful when we start working with snapshots and restoring, we're just going to create a very simple text file on this drive. So to do that, we're going to run this command here. Let me go ahead and get this typed out. So this is basically saying I want to run a shell command which is echoing this text into this file. So that's basically all we're doing. We're just sending literally the line, some text has been written. This caret command is redirecting. So it's redirecting this output into this folder and then into file.txt. So it's actually creating a new file as well, because it currently doesn't exist. So when we press enter there, we could use that cat command again to verify that it was created. And this should print it out onto the terminal. Yep, there we go. Some text has been written. Cool. So now we currently have a new text file that we created sitting on that new volume that we just mounted, attached and mounted. So now let's move into the next part of the lab, which is creating a snapshot of this volume. So you want to make sure, I'm just going to navigate back to the front. This is the main AWS management console. Just make sure that you travel back to EC2. And then down here, we'll click on volumes. Okay. So we want to take a snapshot of my volume, the 1 GB volume that we just created. If we come to actions, create snapshot, we can leave the description blank. Once again, this should have been encrypted. It is best practice, just so you know, but just for lab simplicity, we are leaving that unencrypted. But we will add a tag. So we'll call this name my snapshot and create snapshot. Go ahead and close. And now it won't show up here. So down on the left-hand side menu, you see a separate snapshot section. And wow, that was pretty quick. So yeah, so the snapshot was almost instantaneous. I've seen these sometimes take a couple minutes. So just in case, if yours is taking a couple minutes, don't worry. It will likely complete. You could always refresh in this top right corner up here. Okay, so now we're still in our SSH session, right? So I should have reminded you, make sure you don't close out a PuTTY at all during this because we're going to be jumping back and forth. But now let's go ahead and remove that file.txt that we just created. So we can do that with the command sudo rm, short for remove. And we're just going to give the location of that file. Okay, and now we could use the ls command, which is will list the contents of a directory. So we could say ls mnt data store. You could see that we no longer have file.txt located there. So our file has been deleted from that new volume that we attached. So the next step will be to restore that, and we could do that from the snapshot section. So we'll just have my snapshot selected. We come up to actions. We're gonna create a volume from that snapshot. Make sure to keep it in the same US East 1A. We will not encrypt this volume, although this is really useful if you ever have an unencrypted EBS that you want to encrypt for best security practices moving forward. It's a bit of an annoyance and a bit of a operational issue because you have to create a snapshot of the original unencrypted one and then create a new volume from that snapshot. And in this process, this is when you can encrypt it. So just a security pro tip, like I said, definitely best practice, definitely something you'll run into from time to time, an unencrypted EBS volume. And that is essentially this process that we're kind of walking through right now is how you would fix that. You would just, once again, create a snapshot of the unencrypted volume, create a new volume from that snapshot, and then encrypt it in that process. And then you would reattach it to the EC2 instance, which we're about to do in the next part. So anyways, I'm getting off track, but wanted to share that security best practice. Okay, so we'll give it a name, restored volume. And we'll create the volume and go ahead and close. Cool. So we still have that one snapshot. Now, what do you think is going to happen when we go back to volumes? We now have another volume here, and this is the restored volume that we just restored from that snapshot, and we can see that it's available. So we're kind of in the same place we were before. We have this available EBS volume. Well, what do we want to do with it? We want to attach that to the EC2 instance because we really want to get back that file.txt that we accidentally deleted, right? So we'll just go ahead and click restored volume, actions, attach volume. Let's go ahead and select the lab instance again. And you notice that it gives it SDG, it basically just keeps incrementing alphabetically. Before we had SDF. And then you also do notice down here, newer Linux kernels may rename your devices. And we did actually see this where it renamed the SDF to XVDF. So that's just something that the newer Linux kernels do. But here, we'll just go ahead and attach this. And now we basically want to repeat the steps that we did before. So we have this available, or we've attached the volume, but now we need to remember, create a new directory for that volume, and then we need to mount it. So we'll do that by running sudo mkdir. We're making a new directory in the mount mnt folder, and we'll call this data store 2. And then let's go ahead and mount that to that new folder. And now let's go ahead and list out the contents of that MNT folder. And you can see we have the original data store folder, which is for SDF, and then this one here that we just created for SDG. And if we go into, let's actually change directory. We're in a cd mnt data store 2. And if I do ls, you can see we have file.txt in there. So this is that volume that we restored from the snapshot. And we could also cat file.txt, and we have that text that we wrote out there. Cool. So that's the lab. Hopefully the Linux sysadmin aspect of this didn't trip you up too much. Hopefully, if you're new to Linux, you learned a little bit about file system, administration as well. I know it's definitely very different than working on Windows, but yeah, this is a very common workplace scenario, even if it's not in terms of mounting volumes, but even just as simple as remoting into an EC2 instance. If you're going to be working in the cloud, this is going to be almost like a day-to-day occurrence, or something that you very commonly will do. So that's very good experience to have, to get familiar with, managing those private keys and remotely connecting in. So great. Hope you enjoyed the lab, and I will see you in the next one.